So we're going to start record, and first going to share screen. Let me see, where is my screen? It should be this one. Share screen, this one. And where is that dingo? Oh, hold on, let me stop sharing because otherwise I cannot get, okay. And then I need to share screen again. Okay, so hold on, see waiting room. How do I admit all? Hold on, okay, let me stop sharing for a while. I need to get to the
Zoom.
Yeah, I need to get to the waiting room back. For some reason, each time if I share a screen, then the waiting room I cannot access. I need to stop the sharing screen. Just one minor thing before we start our lecture is just very few of you may forgot about the welcome to our class, the unit on our website. So because some of you think it's just welcome. We may not have assignments, but we do have assignments. So so if you are so if you haven't completed that part of assignments, so please complete them. Oh, probably you first need to send me email so that I will reopen the Dropbox for you. Okay, and then you can complete them. Yes. So just keep close track of all of our assignments. And then we will start our class. So for some of you, it's an old topic, and for some of you, it's new topic in this this part. So today we will move to second unit. Okay. So for reviewing this, going to discuss about the Numpy package. Okay, it's a quite useful package, and most used for numeric calculation. And I will mainly for this note follow the official Numpy quick start, the tutorial. Okay, so for the Numpy package, the number one thing over here we need to hold on. We will need to know is about the Numpy's array. Yeah, so it's called ND array. Okay, and to create a Numpy array, we can create from over here. It says regular Python list or tuple. Okay, and use the Numpy's array function. So here is the example. Is it? And we already learned this is a list, Python list is identified by square brackets, is it? And if we want to create Numpy array, the very first thing you need to do is you need to import the Numpy package. So here we do import Numpy as NP, and then you can just go ahead and use NP for the Numpy package. So following that, then we can just call the array function, is it, and plug in with list in this case. And if you do question mark, you will see what it is it? And the second one, the next one, it's the same thing. We have a list, and then you call Numpy's array function. Then you create array. And if you take a look at the output, is it, here it shows array, is it, array, and then it lists the items in the array. And both of these two are one-dimensional array. Then next, let's see. We have two-dimensional array we can create here. And in this case, we pass in two tuples. So this parentheses tuples, is it? And the result looks like this. And here we need to be careful, okay, for the Numpy array, the two-dimensional. Then two-dimensional, for two-dimensional, if you take a close look, be careful, okay, the outer brackets Is it? This is the outer brackets. Is it? And then within it, you have two sub brackets. And then we have colon. Is it? So this is the first sub brackets, and then we have another brackets. Is it? And separated by colon. Okay. So then in this regarding, this is going to be a 2D array. Okay, 2D array. And the first dimension is kind of by row. So this first sublist, the second sublist. Is it? And then within each of the sublist, so this is column 1, column 2, column 3. Okay. And then later on, we will also see it's basically with NumPy array, you can create multiple dimension, okay? And then in that case, it's not just by row, by column. Then we have the official name to identify each individual dimension. We call it axis, okay? So just be careful about the multi-dimension. And the next example, the next here, this is not too important to us, okay? It's regarding, because NumPy mostly used for numerical, so here it also supports a complex data type, so we know that from math. And what the next couple of cells shows us is regarding the number generate, okay? So with this NumPy function called arrange. So what this function does is you specify some starting number and ending number, but be careful, the ending is exclusive and the step of the number that you are going to generate. And then what it returns is a return array with a sequence of numbers, okay? So over here, let's see. So it said I'm going to generate a sequence number, start at 10, ending at 30, but 30 is not included, and it's every 5. Is it? So that's why I start at 10, and then 15, then 20, and then 25. But did you see 30 is excluded? Okay, so be careful. And over here it says I'm going to generate a sequence number start from 0 and ending at 2, but 2 is excluded. And the step is 0.3, okay? So you can generate sequence of number with this specific function called array. And what the next one shows is we can also generate, in that case, that arrange doesn't specify the number of items, is it? Number of items. It just tells you about a step, is it? And a lot of time you want to know, like within certain range, I want to have certain number of items, is it generated? Then in that case, there is another function called this length space, okay? So if you call this, then it has start and you specify number of items. In this case, this end is included. Okay, so let's take a look at this example. We have 0 to 2, is it? So the first number is 0, the last is 2, is it? And then you specify how many numbers. Is it? Here we have 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9 numbers, is it? So number of items you want this array to have. Then you can use the line space. And here similar, is it? A lot of times when we want to do drawing, is it like the sign, is it? Then you need to generate a number of items. So in this case, it's from 0 to 2 pi, is it? To 0 to 360, and with 100 points going to be generated, is it? And then you can call the sign function, is it? And also regarding this, you will find, so this is an array, ND array, is it? And this F is also ND array. And but over here, it's the sign function, is it? So this function will be automatically be applied on each of the element of the array. So that's why over here we said in NumPy, the operations, so functions going to be applied on array, it's called element-wise. Okay, element-wise. So here, like this, it's because the sign function is going to be applied element-wise on each of the items, so that you don't need a loop, is it? In this case, no loop is needed. Is it? So far, what you have learned is, generally speaking, you need to use a loop, is it? And of course, previous we also learned like list comprehension, is it? With comprehension, then, but even within that, you still needed to write the loop, is it? But you can see with NumPy array, then you don't need to do the loop when you apply certain function, is it? It's element-wise automatically. So that's one of the very nice feature regarding NumPy. Okay, so this is a very important concept. And what next it shows, so over here, it's repeat what I just said. Is that here we have an array created. So A is created with list, is it? And the B is created with this arrange function, is it? Then you call sign, is it? And what is this part returns? It returns an array, is it? Yeah, so that's regarding this part. And then let's move on. And what next part shows is for NumPy, you can do this multiplication operator, is it? Then in that case, over here, let's first take A. A is a 2D array. This is 2D array, is it? And the B is also a 2D array, is it? And 2D array, then in math, then we can understand it as matrix, is it? So for math matrix operation, is it? You can do matrix multiplication, and matrix also has the matrix dot product, is it? The dot product operation, is it? So over here, with this two special operator, and then we can achieve the matrix operation. So the regular multiply operator, okay, multiplication operator, if you apply to this 2D operator, and it's going to be element-wise, is it? So what the result will be is a 2D1, is it, based on matrix? And this is dot product, is it? Dot product, and the result is also a 2D array. Okay, so be very careful here in the NumPy, the 2D array and the multiple dimension. Let me check the chat. Okay, oh, chat. Okay, sorry. It's I thought there's some question, and also if you have any question, you can also just use your audio. Okay, turn on your audio, and so that I know you have any question, I will try to answer your question. And some other operations. Okay, here it says like in other programming languages, is it? And we also learned, is it unary operator like this, plus equal or multiply equal, is it? And here it says those operator will act in place, modify the existing, okay, rather than create a new one. So you needed to be careful, okay? The previous, what we showed is return a new array, is it? And here, if you apply this, then it's going to modify the existing one, is it? And over here, let's see the first one, A. A is at NumPy called once function. This once, and then over here, so this is a dimension. So this is a 2 by 3. Okay, 2 by 3. So it has 2 rows, is it? 2 rows and 3 columns. So this is 2 by 3. And the type of this array will be integer, and it's start with all ones. Okay, all ones. So it will look like this. And then the second one, and then be careful, guys. We have two square brackets. Okay, B is some random number. Okay, this random number generated is also 2 by 3. Okay, 2 by 3. And then let's take a look. If you do A times and equals 3, is it? It's, and then we output A. So you can see A is changed, is updated to 3. Is it all 3? So just be careful, it's on itself. Okay. And then let's take a look at B. So B, the random, is it in this case, random, and over here. So this 2, so the parentheses and the 2, 3, this specifies the shape of the array. Okay, so it's also 2 by 3 in this case, random. Okay, and the random will generate number with what? So between 0 to 1, is it? So it will generate some number between 0 to 1, and it's 2 by 3. So the shape is going to be the same as A, is it? But it's just some floating number. And then you see, if you do B plus equal A, is it? And what it will happen is update B, is it? So that's why B all have 3 plus something, 3 dot something, is it? So that's regarding those operators. And what next one is going to show us, oh, I already kind of explained, is it? So this 2 comma 3 within parentheses, this is not a tuple, okay? So don't get confused, because it's a different function. It's called random. So random function, the parameter, the first parameter, when you use the tuple to specify, to represent the shape, okay, it's for shape. And the number will be between 0 and 1. Okay, and for NumPy, for the array, you can call like some summation. Is it? Summation means a certain number of accumulation operations. So if you just call sum, is it just call sum? And if you don't spec, because this is 2 by 3, is it? It's a 2 by 3. So you have 3 numbers, is it, for each row? This is 2 by 3. And if you call this sum, just sum, without specify anything, so it will do the addition of all of the items from the array. So that's how the result comes, is it? And if you said, oh, sometimes I just wanted to find the summation of each row or the summation of each column, is it? Then how do I do that? Over here, you see, it's called a.sum. Here, specify. So this is a keyword, axis. So you specify the dimension, is it? So axis equals 0, is it? So 0, so if you say axis equals 0, that means the first dimension, is it? So first dimension, what does that mean, is it? So it's sum of the elements for the first dimension, is it? So it's going to, so first dimension, like we just said in this 2 by 3 case, it's a row, is it? It's a row, but it will do summation for what? So that's why the result, you will see you have 3, is it? So it will keep the column, is it? And so over here, it will do summation. If we have more, is it? Then it will do basically elements from the column, and it's sum them, is it? So if you specify like this, and then you will have the corresponding results. Is it? So it's by the column, is it? Or it's do the summation along the column, is it? But it's for row, is it? So for first dimension. And then let's take a look. If you do x is equals 1, so 1 then is the second dimension, okay? Second dimension. Later on we will see you can have more dimension, is it? Then in this case, it's going to do summation by the row, is it by row? But it's sum the column items, is it? So that's why, so it's sum the column items, so sum the second dimension items, is it? But along what? Then it's along the row, okay? So be careful about the axis equals 0 or 1 or 2, okay, something. So it means for the dimension, okay? And then next, let's see. You can also reshape, okay, reshape the original array. So with this arrange, so this going to give you 1D, is it, with 12 items, elements, is it? And then you call the reshape function. So reshape, then it's what? It's 3 by 4, is it? So that's why the result, if you take a look, so along axis is 0, you have 3, is it? Along axis is 1, we have 4, is it? So first dimension is 3, second dimension is 4, is it? So the first dimension, we have each of the sublist, is it? So each of the sublist is the first dimension, okay, first dimension. And this is the second dimension, okay, the column. So that's what B looks like. And then how do we specify like a specific dimension? So get the specific of the elements from specific dimension, is it? Let's take a look. There are a number of ways we will see, okay? So here is a case. So you see, if you do B square bracket dot dot dot, and here is a comma, is it? And then 1, is it? So then this means this is for second dimension. Second dimension. The dot 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 is for first dimension. First dimension. Okay, so dot 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 for first dimension, that means what I want. So that dot dot basically is slicing. So for first dimension, I'm going to do slicing. So what that means, I'm going to get all 3, is it? So this is 3 by 4. So I will retrieve all 3 first dimensions, so all 3 sublist, is it? But regarding second dimension, I'm going to get the second, so it starts at 0, is it? So for second dimension, I'm going to do indexing. In this case, so index is sub 0, this is sub 1, this is sub 1. So it will get all of those items. That's what this means. This is quite useful, okay, with NumPy array. So you need to do the selection. Like some region selection, is it? Some blocks, you select certain items, is it, from the big array, is it? So here it shows how do we do using slicing and indexing. So this is just shows. So if you use data, that means all the first dimension. So depends on the dimension, is it? This is also equivalent to this, is it? And previously we learned, is it? The colon, is it? And if you don't specify, that means everything, is it, from the beginning all the way to the end. So this is for the first dimension, it's slicing, is it? Because we have colon. For second dimension, because you don't do slicing, you just specify the specific item. So that's indexing, is it? So that's why you get this. So it's the result is what? Is a one-dimensional array, is it? So this is also kind of you reduce the dimension, is it? Okay, so that's shows some examples. So next, let's take a look at the next part. So reshape we already explained, is it? We already explained. And then next, let's take a look. And for NumPy, you can also delete certain thing, is it? Because sometimes you have the big array, you said, oh, I want to delete certain rows or certain columns or certain sub section from certain dimension, is it? But let's see this delete function. Then you can call this delete function. So what over here is delete on what? On this array, is it? ARR. So this is a 3 by 2. Is it from 0 to 12? So it's from 0 to 11. Is it? The range, and it's a 3 by 4. So originally it should look 0, 1, 2, 3. That it should be 0, 1, 2, 3. And then 4, 5, 6, 7. Something like this. That's the original. Is that? It's 3 by 4. And what here delete is delete on this guy. Is it? This is ARR, delete on this guy. Along which axis? Along second dimension. So this is regarding all of the second dimension. Is it? So regarding column, is it column? Okay, second column, which one? The third one. So I'm sorry, I crossed the wrong thing. So it's going to delete this one. So it's the second dimension, which item? The third item. So it will get 2, get 6 from each of it. So that's why you have 0, you have 1, you have 3. Is it? I have 4, 5, and 7. Is it? That's the result. So it's reduced to 3 by 3 array. Okay. So that's regarding this part. And then the same thing, is it? You can also find the mean along which axis, so which dimension you specify, is it sum? And another one is called cum sum, is it? So cum sum, the idea is like this. So the original ARR, is it? Oh, here is B, is it? B, B I think is 0, is it? 0, 1, 2, 3, something like this, is it? And then 4, 5, 6, 7. Something like this. Is this a B? Okay, you said I'm going to do the cum sum. Is it along second dimension? Is the second dimension is along the column? Is it? So what it's going to do is, that's why the first one is still 0. And it's going to add the first one to the second. So it's 1. Is it? And it's going to add 1 to 2. So that's why how you get 3, is it? And then you're going to have the previous summation, then add the current one. So it's always add, is it? So 3 plus 3, so that's why you have 6. That's why you have 0, you have 1, have 3, you have 6. Okay, so this is what cum sum means. And then next, let's see. So basically, this is similar as what we previously said. So it's always in NumPy array. So for the functions, when you apply to an array, it's going to happen as element wise. So you don't need to write a for loop, okay? You just directly call, you see, this exponential function, is it, on this array? Because B is an array. In previous, so far what we have learned, if you want to find the exponential, then you need to use a for loop, is it? But here you don't need, because it's element wise, okay? You just directly plug in that array, then it will return you the corresponding array, okay? No more a loop needed here. So it's quite interesting. And what next is says in a NumPy array, how do we do indexing, slicing, and iteration? Is it? So let's take a look at examples. Over here, A. And A is what? It's with a range, is it? So it's a 1D array, is it? With 10 elements. Is it with 10 elements? So it's going to have 0, 1, 2, 3, all the way to 9, is it? But be careful, it's going to do what? It's going to apply this operation to this array, as previously we learned. So it's going to do cube for all of that, as if for all of that. So that's why when we print A, we have this result. Then we have this result. And then the most interesting thing is this. Oh, sorry. Okay, and then what we have here, you see A, is it? And with the brackets within it, what is this? This NumPy array, is it? And this is a list. So this is a list. So list. And then you call array. Is it? You call that np.array. Is it? So what will it have generated will generate an ND array. The ND arrays have 1, 3, -3. Is it? And then you said, okay, I'm going to apply A. What does this mean? This is weird looks, is it? So basically, this integer array is indexing, is doing indexing work. Okay, what it means, okay, this is A. This is A. It means I'm going to retrieve the second item and the fourth item, 0, 1, 2, 3, the fourth item. And -3, who still remember negative number indexing, what does it mean? It means reverse, yeah. So count from back, is it? The third one, okay. So it should be -1, -2, -3, is it? So it should be this guy, is it? So you see, so it retrieves these 3 items. So if you have an ND array, and originally you have this array, is it? And then if you want to do indexing, but with specific item, then you can plug in with another integer ND array, okay? And then this is going to do the indexing for you, okay? And you see, so far you have learned from other language, what you can do is you need to use a for loop, is it? Oh, if you reach that index, then you append it to another new array, is it? No, you see, in NumPy, it's so easy, is it? You just plug in another integer array. So this is not, so be careful, okay? This time we also have 2 square brackets, but this has nothing to do with our dimension of the array. This inner dimension, this inner square brackets, it serves as indexing. Indexing, okay? So be very careful here. Okay, we understand this. Then next, let's see what the next one is. Okay, then over here, this is definitely indexing, is it? You said, oh, I want to change the first item to -2000, is it? So you see it's going to be changed if you do the printout, is it? And then what next one shows? Is it? What does this mean? Is it? This is equivalent to, because we didn't specify starting index. So starting from 0 if you don't specify. And previously we said, this is for slicing, is it? Slicing is start, end, and step, and with colon. separated that. So it starts at 0, ending index is 6, and it's every 2, is it? So it does slicing, is it? So the first one is going to change it to negative 1,000, is it, every 2? So it will change this guy also to negative 1,000, is it? Until so 0, 1, 2, 3, 4. Then it's also going to change, is it? And not included. You remember we said in slicing, this is not included. So this is excluded, is it? So that's why no more, is it? But you update the corresponding I. So you see, you can also using slicing to do updating. And what the next one shows, this is indexing, okay? But this dot, 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 dot means everything, is it? So it's equivalent to this, is it? Equivalent to the slicing, the dot, 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 okay? And over here, what it shows, it's a first dimension, is it? So over here, a dot, 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 and then 3, is it? So first dimension, is slicing, is it? That's slicing. So for A, then it will take all of the I. But in this case, A is a one-dimensional array. Is it? A is a one-dimensional array. So that's why it's basically just equivalent to indexing. Is it to indexing? So it's very tricky, okay, when we take a, but if it's two-dimensional, is it? Then that means first dimension you do slicing, second dimension, then you're going to do indexing, okay? But over here, A itself is one dimension, is it? So it basically it's said it's equivalent to indexing, okay? And what the next one shows is the same thing, okay? So this is regarding indexing and slicing. And the next one also shows how to do reversing, is it, with negative index. So this is similar, the negative index, as previously we discussed. Okay, what the next one shows is this called from function. Numpy is a function, from function. What it plug in is some function, the first parameters. Second parameter is the shape. Okay, is a shape going to be generated. And the third one, previously in our review, as we learned, for the functions, if you have, we have the single asterisk and double asterisk. This is args, is it? And this is keyword args, is it? And this is for variable lengths of arguments, is it? And if you have double asterisk, that's variable lengths of key value, is it, arguments. So keyword arguments, is it? So that's a difference, okay? Over here, let's see. We call this function, we plug in with whatever the function we defined, f, is it? And the shape is going to be 5 by 4, is it? And the key value pair, so for the data type, it's integer, is it? That's what this from function does. So what this means, it means it's going to conduct calculation with this specify f. So f is 10 times the first one and the second one, is it? So the first one will start from what? From 0 to 4. Second one will start from 0 to 3, is it? So that's how you comes with this array. It's 5 row and 4 column, is it? And the data calculation will also be based on this 5 and 4. Okay, so that's what this from function means. Okay, and if you recall, is it? And I strongly recommend you try this. Okay, if you have some very short calculation, try to use the lambda expression. Is it? So the from function, the first part is some function. Is it? And the lambda expression is anonymous function. Is it? So this lambda, it has 2 parameters. This is a function body, is it? So same thing, you can also rewrite that with lambda expression, is it? So this is the beauty part of Python language, is it? It's very concise. You can write very concise. Otherwise, with regular way, you need to write loops, is it? And should be involved with 2 level of loops. Okay, and what next one also show? We already learned this. Is it first dimension do slicing, second dimension do indexing? Is it? So nothing new here. And the next one for this B, the first dimension is slicing, second dimension also slicing. Is it? So you do slicing on both dimensions. And for this one, it's just you do indexing, is it indexing? And this is the last row, basically, is it? Okay, next explains the ... with brackets, okay? So let's take a look at this example, okay? So it depends where, so the ... happens where, is it? So over here it shows like X. So first dimension is index, second dimension is index, all of the remaining dimension is for slicing, is it? Then for this one, it's the last dimension is indexing, all of the other dimensions are slicing, is it? And here specify, okay, first dimension is indexing, and between some dimension, it's indexing, it's all slicing, is it? Last dimension is also slicing. So you can see it's quite concise, is it? Very nice way. So now let's take a look. So be very careful here. It looks like a 2-dimension. No, this is a 3-dimensional array, is it? We have 3 brackets. We have the outermost one, is it? And then did you see, you have this second level, you have comma here, is it? And then within this second, you have comma and comma, is it? So that's why this is a 3-dimensional array, is it? So if you call, and how many dimensions it is, you can call the shape, is it? If you call the dot shape, it will tell you, okay, first dimension has 2 items, second dimension has 2 items, third dimension is 3, is it? So first dimension separated by the first comma, is it? So then you have this level, is it? So this is first dimensions, first item, first element. And itself is what? So first dimension itself, this item is what? It's a 2x3 array, is it? Itself is already a 2x3, is it? And then for this one, then this is going to be the first dimension. So this basically is second dimension, this is third dimension regarding the previous one. And then let's see, it says C1, 1, 2. Then we don't have any colon or ... is it? So it means it's indexing for all dimension, is it? So it will retrieve the first dimension, second item is which one? It should be this guy, is it? The big 2x3 one. And regarding second dimension, the second item, it will be this guy. Is it second dimension, second item? And the last dimensions, a third one. So it will be 1, 1, 3. Is it? That's how you get each single dimension. Okay, so be careful here. It's quite useful. And then let's see the next one. What it shows is that it does something like this. So this is equivalent to what? First dimension indexing. Is it? And the remaining dimensions, so second and third dimensions is slicing. Is it? That's what this means. Okay, first dimension, it will get what? Get a second item, second element. It's this big chunk. Is it? And it will do what? Slicing on the second dimension. So everybody. Third dimension, everybody. Is it? That's how you come up with it. Okay, then next, let's see this one. This one is the last dimension is indexing. The first two dimensions are slicing. That means, okay, I'm going to get both first dimension. Then I need to get all within each of it. It's kind of messy what I circle. So basically, everybody should be included regarding if just the first two dimension. But for the third dimension, it's going to take what? It's going to take the last item. So that's how you come up with this array. But it's reduced to what? To a two-dimensional array. Why? Because if you take a close look, because from this square bracket take 1, and from this bracket will take a 1. But both of this included within a bracket, So that's how this happens. And logically, it's also, because only one dimension is indexing, of the remaining dimensions are slicing. So of course, it's just reduce one dimension, So that's why it's reduced from 3D to 2D, okay? And then next, let's take a look. For this one, this array B, it's also a 3D, 3-dimension. It's similar as what we learned before. So over here, what does that mean? It means the last dimension, I'm going to do indexing. Second items? But of the remaining dimension, what I'm going to do, I'm going to do slicing. That's how you come up with this array. Okay, and what over here I'm trying to show, if you want to iterating, and with a certain dimension, I wrote this kind of loop like this, okay, you loop, because this is 3-dimension. This is a 3-dimension, So your first loop, you get from the first dimension, First dimension is what? It is this, and this, So the first part and second part, First dimension, second dimension, And for the second dimension, because second dimension is what? It's a 2 by 3, 2 by 3. So that's how I'm going to loop for the second dimension, but it's within what? Within the first dimension, this first dimension, it's going to be a what? It's a 2 by 3 array, And B is what? B is a 2 by 2 by 3 array, So that's why how I can do the loop, So I print each item. So within the second dimension, I get each of this, But I have a blank line, within the first dimension, second dimension. So that's how this works, okay. Okay, and if you wanted to flat, so to make a multiple dimension into one dimension, you can just do something called the flat function. Okay, so quite straightforward. And what next? Shape. We can also change the shape. Is it? And with regarding random number, you can also do random integer number. So you specify the range. Is it? And here tells the shape about the random array you're going to generate. Okay. And with random, we can also call this rand function. Rand function is you just plug in the shape directly. Is it? Be careful about rand and this random. This random, so rand is just directly plug in number, okay, specify the shape. Is it? And with random, you need to have the parentheses. Okay, so that's the difference here. So that's just some subtle difference if you want to use. Okay, and the floor function in NumPy array, is it? It's just to get the largest integer, is it? That meet. So if you have this 3 point something, the floor, it's going to be only take the integer part. Okay, so that's this whatever that function defines. Okay, and for reshape, previously we already say is that reshape you can. A initially is what? A initial is 3 by something. Is it? I don't remember. 3 by 4 maybe. Is it? And if you reshape 6 2, it's going to have 6 rows and 2 columns. Is it? You can also call revel. Is it? And you can also do resize, but be careful. It's resize. It's modify array itself. Okay, reshape and the reshape and revel, it's not on itself, it's generate a copy. Okay. Okay, and we're kind of running out of time. And let me, where is the, I